Welcome to Module 49 and 50. So we're going to talk about some atmospheric ozone and atmospheric pollution. So Module 49 is stratospheric ozone depletion. So when we look at this, it's really important to know the ozone formation equation. So we've got O2, which is our normal oxygen that we breathe, plus UVC, which is a type of UV radiation from the sun. So there's UVB, UVC. And so that combines with O2 and breaks it apart. So it basically breaks it into free oxygens. And so those free oxygens are wanting to combine with something else. And so what they combine with is O2. And so O2 plus O yields O3. And O3 is what ozone is. And so this is a constant breakup and breakdown, or build up and breakdown. So basically O3 is constantly forming and breaking down. So UVB breaks it down, UVC builds it up. So you can see here, just know this equation. So O2 plus UVC yields free oxygens. A free oxygen plus O2 yields O3. And then that constantly breaks down. So in the presence of UVB, it breaks down. And that's what ozone is constantly forming and breaking down in the stratosphere. So hopefully it stays in the stratosphere. If it doesn't, O3 on the ground is what we refer to as smog. Stratospheric ozone is important. So stratospheric ozone is where we want the ozone to stay. And so what that does is that it blocks the UV rays that are coming down to Earth. So it basically protects us, protects organisms, protects plants from skin cancer, cataracts, immune system suppression, also protects plants from overexposure. So that's what ozone does. The breakdown of ozone leads to an increase in those things. So an increase in skin cancer, cataracts, immune system suppression, plants being burned unnecessarily, and things like that. So the chemical involvement, the things that break down ozone would be CFCs. So CFCs used to be really popular, especially in like hairspray and things like that, like aerosols. But we found in the early 90s is that CFCs, they're chlorofluorocarbons. And so they produce chlorine into the atmosphere, and chlorine can react with oxygen or ozone and break it down. And so basically this is the equation here. So O3 plus chlorine yields ClO plus O2. So this is not ozone. And so it breaks it down into oxygen that we breathe, but it's not ozone. And so that's what led to the hole in the ozone. So they used to talk about a big hole over the Antarctic, and that was a hole in the ozone. And so it's decreased significantly since we've began not producing CFCs, but it's still there. It's coming back though. So ozone is definitely something that's repairable because it's a constant buildup and breakdown with oxygen and ultraviolet light. So it definitely is renewable. So it is coming back, but we found that CFCs reduce that. And so we banned them, but CFCs can stay in the atmosphere for 20 or 30 years. And so it takes a while for it to break down, even though we've stopped using them in the early 90s. It's taking a while to break down. So that was part of the Montreal Protocol. So the Montreal Protocol banned the use of CFCs, and they also banned the use of 96 other ozone depleting substances. So that's part of the Montreal Protocol, which we'll talk about a little bit later in Unit 8. All right, so ground level ozone, which is tropospheric. And so know the difference. So if on the test they talk about stratospheric ozone, that's the good ozone. Tropospheric ozone, troposphere is where we are. So tropospheric ozone is the bad ozone. So that's in the lower troposphere, which is where we are. So this increases lung function, so we can't breathe as well. Respiratory symptoms, it's not great for basically anything. And it just breaks down things. And so it's produced by secondary pollutants. So it's formed by VOx, NOx, and water and oxygen. So that's kind of what those things involved together produce ozone on the ground. So if we look at the EPA standards, which is the Environmental Protection Agency. They reported 46 regions that didn't comply with the max allowance. So the max allowance is 0.075 parts per million per 8 hours. So in 2013, 46 regions on Earth did not comply. So they're monitoring that, and there's not regulations everywhere. So the U.S. has, I wouldn't say tight regulations, but they have regulations on the amount of smog. But overall in the world, not so much. And so a lot of developed countries definitely, but the developing countries don't. And this is part of the Montreal Protocol. So a lot of the developed nations are part of the Montreal Protocol, which is basically tackling pollutants in the air. And like I said, we'll talk about this later. So you just need to kind of be familiar with that term. But we'll talk about that exactly what that Montreal Protocol is later. So that was it for 49. So 50 is indoor air pollution. So that was basically outdoor, stratospheric, tropospheric, ozone. So this is what's happening indoors. So there definitely is indoor air pollution. So in developing countries, the type of indoor air pollution that we can see is from burning biomass. So biomass would be exactly what you see in this picture. So they're cooking on wood, they're cooking on burning, some people burn their garbage. And then some people burn wood or whatever they can find. So that produces carbon monoxide, and carbon monoxide is a silent killer, basically. So it doesn't have any smell, and it makes you just sleepy. You go to sleep and you don't wake up. And a lot of newer houses, they have carbon monoxide detectors, especially if you have natural gas or some kind of propane or something like that in your house. It's very important because incomplete combustion can cause carbon monoxide poisoning. And so, like, let's say that your power goes out, for example, and you decide, well, I've got a camping stove. I'm going to use my camping stove. Well, there's incomplete combustion. It doesn't combust like your stove does. And so it can produce carbon monoxide. And people, a lot of times, I mean, every single year, somewhere where the power goes out, people die of using indoor stoves, like camping stoves when they're indoors. And so don't do that. It produces carbon monoxide and can kill you. And so carbon monoxide poisoning is very often happens in developing countries. All right, so VOX. VOX are volatile organic chemicals. And so any kind of smell you smell with anything. So like that new car smell, the new paint smell, you buy something new and it smells, that's all VOX. And so it could be glue, formaldehyde, new carpet, for example. We kind of associate those things with, oh, it smells good, like a new car. Well, it's actually really bad. So anyways, you're smelling glues, formaldehydes, detergents, all kinds of weird things. So these are just some examples of things that you might, so basically anything that smells in your house, not like a fabric softener, air freshener, but things that are plasticky or gluey or anything like that, those are VOX. And so those aren't necessarily good for you. Asbestos. So this is another thing that could be in the house, especially older houses. So that could be in the walls. It could have been used as insulation. And so pre-1980s, that was very common. And actually the reason, let me move my picture. Actually the reason I have the picture of, the Wizard of Oz here is because they used asbestos. So the I don't know if you guys remember the scene where they were frolicking through the flowers almost to Emerald City, and it was snowing, or actually they were breathing in pollen or something. I can't remember the exact thing, but they're breathing something, some kind of poison. And then the Good Witch made it snow, so that it would block that pollen that was making them go to sleep. So that snow that they used was asbestos. So it was like literally snowing asbestos, all over them. But that was before we understood that it was actually really bad. So it can cause some serious lung problems. And so it's really important if you have a house that's pre-1980s, if you have a flocked ceiling, like a bubbly kind of rough ceiling, chances are that's asbestos that they used. And so you have to have like basically a hazmat team come in and clear your house of any asbestos, because it's a pretty serious problem. So just keep that in mind if you ever buy a house that's pre-1980s, have it checked for asbestos before you buy it. for sure, because it's very expensive to have that removed. All right, and then radon. So radon is an invisible gas. Radon is natural. It's from decaying uranium. It's very common in the Midwest. So there's quite a bit of uranium decay there, and so it's natural, but it can be more prevalent in certain areas of the country. So it comes in from the ground. So it's also more prevalent in the Midwest because they have basements. So generally in the West, here we don't have basements because our ground is too hard. So in the Midwest, it's not though. So it's very easy to dig. And so it's very common to have a basement. Plus it's good protection from tornadoes. But radon seeps in through the ground. And so if you don't have crack sealed or if you don't have good sealant in your house, you could have radon poisoning. And it could cause lung cancer. So it's very good to know that and kind of test for that and make sure you don't have any leaking seals or anything like that. All right, and then sick building syndrome. So what this is they found that people that spend a lot of times indoors are more sick than people that are outdoors. And so what they found is that people indoors are rebreathing air. So think about all the things that you're rebreathing everybody's air, but you're also breathing in all those vox. So you're breathing in glues, carpeting, furniture, all that, new smell that you smell. You're rebreathing that over and over. Whereas outside, outside is huge. And so you're breathing fresh air. And so people that spend a lot of times in buildings, big buildings, indoors, don't go outside much, they are much, much sicker than people that are outdoors. And they even said that during COVID. They said basically get outdoors. COVID, it spread more easily indoors because you're rebreathing air, but go outside, fresh air. It just is really good for you. And so I put on here, go play outside. So it's really important to be outside as much as you can. Not just for this, but just for general health and well-being and stress levels. Think about the last time that you guys went outside and maybe you're stressed out, you go outside, and I don't think anybody gets stressed when they go outside. There's no way that if you go for a hike, you're going to be stressed out. So it's just really good for your mental health, physical health, to get outside. And so that's my word for the day. But anyways, that's it. So that was it for Module 50, and I will see you guys next time.